So hi, we are the asthma monitoring inhaler, also known as the Exhaled NO2 monitor. My team members are Allison Earhart, who worked primarily on the enclosure for the device, Timothy Huynh, who worked on the firmware development, Lance Fierstor, who worked on our sensor and sensor characterization, and I'm Alexander Smith, and I worked on both the phone application as well as the hardware, the PCBs and things like that. So the overall problem we're trying to solve with our product is currently how asthma attacks are managed. So right now it's very reactive, as in you start to feel symptoms like difficulty breathing and chest tightness, and then you take your medication. So we tried to create a more proactive solution to that by developing the asthma monitoring inhaler. And the way our inhaler is different is not only does it dispense medication, but it will also allow the user to breathe into the device. And it will then take a chemical measurement, specifically NO2, in the breath to determine their risk factor for having an asthma attack in the future. That way they can take their medication before symptoms even occur. So how we implemented this solution was with, first, the primary component is our sensor, which is a metal oxide sensor that is used to capture the breath and determine the chemical reading. We then pass that through to a microprocessor, which will then take the reading and then send it over Bluetooth to a phone application. And that phone application will then do some processing on the signal and convert it to a concentration in the air. And then using research from pulmonologists and other specialists in the field, we can then correlate that concentration to their risk for an asthma attack in the future. So our hardest challenge in this project was how small we had to get the inhaler. We wanted it to stay as close to a traditional inhaler as possible to make it a seamless experience for the user. However, the problem with this was that we then had to compress all this functionality into a very, very small board to be able to implement this. And this provided difficulty both with power, because we couldn't use a big battery for a longer lifespan, as well as just what sensors we can put on the board. We had to go with one sensor because we just simply didn't have enough space to put anything else on the board. So getting that concentration reading from one sensor proved difficult. So the biggest thing we learned technically was how to get all these different components, being like software for the phone application, firmware for the microcontroller, and hardware, and kind of pairing them all together to make a product for the user. That was something we never really done before. Each kind of class we'd taken focused on individual aspects of this, but getting it all together in one product for a user was certainly a good experience for us.